Welcome everybody to the part 1 of this test review guide on radicals and rational exponents. So on this front page, it is about radicals for the first 4 problems, and the last 2 problems have rational exponents, which we don't probably will need to use radicals on, but we'll see. Anyways, here's the first problem. The first problem is actually pretty straightforward, because the first step when you do these problems is to get the radical by itself. But in this case, on the left side, the radical is already by itself, and same thing on the right. So it turns out if you just go ahead and square both sides immediately, square roots just kind of go away, and all you have left is 4x plus 1 equals x plus 10. So it's an easier problem because they're both square rooted. After that, it's just solving for x. So you have to get x on the same side. So we'll subtract an x to get 3x plus 1. That goes away, equals 10. After that, subtract 1 from both sides, and you get 3x equals 9. And then divide by 3, cross that out, and you get x equals 3. I'm just going to go ahead and quickly check that answer. Sometimes it doesn't work on some problems, so I'll just check. If you plug in 3, 4 times 3 is 12, and 12 plus 1 is 13, so you'd have root 13. And then 3 plus 10 is 13, so you'd have root 13 again. So this does work out. All right. Number 2, not as easy. The root is by itself, the radical is by itself, so the first step is going to be to square both sides. Just keep in mind, squaring the right side is not as easy as you might think. On this side, the root's going to go away, so you end up with x squared plus 4. But whenever you square something that's 2 terms, make sure you are writing it twice and foiling it. So to do this, I'd have to do x times x is x squared, 5x, 5 times x is another 5x, and then 5 times 5 is 25. Combining like terms, you get x squared plus 10x plus 25, like so. All right, solving for x in this case, it looks like we have different types of x. We have x squareds as well as regular x. So we're going to try to get everything on the same side. And it just so happens in this case, if you subtract x squared from both sides to move this over, this cancels and that also cancels. So you just have a 4 on the left side, which is going to make life a whole lot easier. Because now you just have to solve for x. You can subtract the 25 over and then divide by 10. And we'll see what we get. Negative 21, 10x. And we'll divide by 10. So x equals, you can either write negative 21 over 10, that's it as a fraction. If you put it in calculator, it'd say negative 2.1. Either of those I would accept. And once again, I'm just going to double check to see if it might work. So negative 2.1 plus 5, that's going to be like a positive 3.1 or something like that. And here, if you square it and add 4 and take the square root, it's probably going to work. I'm not going to super check it. The big thing is that it wouldn't work if this turned out to be negative. That's what you usually have to check for. If you plug in for x and this turns negative, then it definitely can't work because no square roots will ever turn negative. So, but you know, you're welcome to put it in the calculator to find out. 3 is pretty similar. The root is already by itself, so you square both sides. At this time, what I would do if I were you is I would pause the video and see if you can work through it yourself. So do that or don't. Root goes away, you end up with 3x. And then once again, you have to write this twice and FOIL it out. And when you FOIL and combine like terms, you would get x squared minus 12x plus 36. Okay. Now this time there is going to be an x squared and an x here, which means that you're going to have to do some more steps. mainly, if you ever have an x squared and an x and nothing else will cancel, you have to get everything on the same side and factor it. So you have to subtract 3x, so it'll be equal to 0. Because before you're allowed to factor, it has to be equal to 0. So negative 12 and negative 3 is negative 15. And we'll see what it factors into. Okay. What multiplies to 36 and adds up to negative 15? And you find those numbers. So multiplies to 36, that'd be like 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 does not go into it, 6 and 6. Okay, so one of these will somehow get you 15, and it looks like it's going to be the 3 and the 12, or negative 3 and negative 12. Like so. And then if you set these equal to 0, you get x equals 3 and x equals 12. Ta-da! Just like that. Except not. Because as it turns out, as I kind of did on number 2, if you were to plug in 3 minus 6 is negative 3. And if you did 3 times 3, you'd get 9, and the square root of 9 is positive 3. So it turns out this 3 doesn't actually work. Once again, that's because this turned it negative, and square roots will never be negative. 12 should work. 12 minus 6 is 6. And then 12 times 3 is 36. So it would be the square root of 36 equals 6, and that is true. So that one does work. Over here, unlike the first 3, the radical is not by itself right now. There's a negative 4 in front and a positive 3 over here, so you do have to get it by itself first. They call that isolating. We're going to isolate the radical. So we have to get rid of the negative 4 and we have to get rid of the 3. So do you remember which one you get rid of first and how? The answer is the 3. You subtract 3 and you get 12. Next up, getting rid of the negative 4. How do you get rid of the negative 4? The answer is through division. It is negative 4 times the cube root of stuff. Since it is multiplication, you do have to divide to get rid of that negative 4. Do not add it, it is a divide. We already added, subtracted, so the next step's got to be multiply, divide. And 12 divided by negative 4 is negative 3. So negative 3 is equal to the cube root of x plus 10. This time, it's not a square root, it's a cube root. So what you're going to have to do is to put both sides to the third power to cross it out. Put it to the third power. Negative 3 to the third power. Negative 3 times negative 3 is positive 9. And positive 9 times negative 3 is negative 27. Subtract 10 and you're done. Probably. Actually, that's right. Cube root. Cube roots, you don't have to check for negatives and stuff, because cube roots are allowed to be negative, so that'll work. Okay, and the last 2 questions on this page, once again, don't have radicals, at least physically written down. So what you have to do is this time get the parentheses with the exponent by itself. So we'll subtract the 22, so it'll be a little bit easier looking. And 150 minus 22 is 128, I believe. Yes, it is. Okay. From there, in order to get rid of this exponent, what you want to do is put both sides to the reciprocal. So instead of 7 over 3, you put to the 3 over 7 power on both sides. That way, 7s cancel, 3s cancel, all of this is gone, you get 3x plus 5. Once again, it's the reciprocal. Reciprocal, ta-da. Use the reciprocal exponent. And then 128 to the 3/7 power. Well, you can do it by hand or you can do it in a calculator. I'll just show you a calculator real quick. I mean, I already know what the answer is going to be, but that's because I'm a nerd. Whoop, whoop. 128 to the 3/7. And it's really as simple as that, just putting it there and typing it in. So it's equal to 8. The whole thing right here, 128 to 3/7 is just equal to 8. And you subtract 5 to get 3, and divide by 3 to get 1. And you could plug it in again just to make sure it's right. So that would be like 3 times 1 plus 5, and I forgot to put the parentheses, times 1 plus 5 to the 7/3 plus 22, and it should say 155. Let's see. I'm sorry, 150. And it does. It says 150, so it's good to go. Cha-ching. So let's go ahead and try this one. Same step as the last one, except this time instead of a 22, it's a 73. We'll add. So 170 plus 173. I don't know why I did 173. It is totally just a 73. So 243. All right, see if you can guess the exponent. What exponent am I gonna raise it to? You got this, I have faith in you. There's an announcement that's going on. So just ignore what's going on because it doesn't relate to you at all. Good times. So you take the exponent 5/3 and put it to the 3/5. Because that's once again the reciprocal. So all that crosses out, and you get x minus 5 is equal to this thing. Well, it's once again, you can do by hand, which I can show you, but easy way is 243 to the 3/5. And it's 27. Yay. Don't you just love it when it's whole numbers? Okay. If you wanted to do it by hand, which I'm going to show you because I love math, 243, if you were to rewrite it with rational exponents, the bottom number, the 5, becomes the root number, and the 3 stays as an exponent. Now, you probably don't know by just looking at it, but 243 is a perfect power of 3, like 3 times 3 times 3 times 3 times 3, I think. Yeah, there we go. So if you have 1, 2, 3, 4, 5 3s, then it turns out this whole thing right here, if you just kind of do the whole 3 and 81, 9 and 9, 3 and 3, and you look for 5 of a kind, you have 5 of a kind. So this part right here is equal to 3. You bring down that thing, 3 to the 3rd, that's equal to 27. Woo! Cha-ching. Awesome. Isn't math awesome? Don't answer that. Okay, see you guys for the next video.